Welcome back to yet another episode of Planetarium, where we discuss space chronicles beyond Earth. The mystery of black holes has intrigued astronomers for many centuries, with many of them constantly looking for them in space. In today's video, we talk about a recently found piece of information regarding the collision of two black holes. Before delving into the specifics, let's briefly discuss what exactly is a black hole. A black hole is a region in space where the gravitational pull is very intense, such that light and electromagnetic waves cannot escape it. This phenomenon occurs when matter becomes compressed into an incredibly small space, often resulting from the death of a star. From a distance, due to the absence of visible light, this area appears as a large black void, hence the name black hole. Despite being invisible to the naked eye, space telescopes equipped with specialized tools can observe the difference in the behavior of nearby stars versus those further away from the black hole. Black holes can range in size, with some as tiny as an atom, but with a mass equivalent to that of a massive mountain. Astronomers have been monitoring a supermassive black hole located approximately 9 billion light-years away that is accompanied by a smaller black hole in orbit around it. This observation has been ongoing for a considerable period. The orbit of the companion black hole has been observed to gradually decrease, indicating that it's moving closer to the supermassive black hole. Consequently, it is expected that they will eventually collide and merge. The largest type of black hole currently known is the supermassive black hole, with a mass ranging from hundreds of thousands to billions of times that of our Sun. These black holes are typically located at the center of our galaxies, and scientists are actively seeking to uncover the mysteries of their formation and existence. It is widely believed that black holes merge with one another over time, eventually resulting in the formation of a supermassive black hole. In fact, many astronomers suggest that at least one merger must occur to create a supermassive black hole. Another example of this phenomenon was observed in the OJ-287 galaxy, where two massive black holes were observed, with the smaller black hole orbiting the larger one. The larger black hole was also observed to be surrounded by a disk of gas. As the smaller black hole spirals towards the gas disk of the larger one, it collides with it, resulting in a flare that shines brighter than 1 trillion stars. On observing the OJ-287 galaxy, it was found that it hosts one of the largest black holes ever found, which is 18 billion times the mass of our Sun. This is orbited by another black hole that is 150 million times the Sun's mass. Twice every 12 years, the smaller black hole crashes with the bigger black hole, creating an effect that is even brighter than our Milky Way galaxy. However, it takes around 3.5 billion years for this flare to reach our Earth. Back to the black hole duo in consideration, this pair is called a binary, and the smaller black hole is known to circle the bigger one about every 2 years. Based on recent observations by scientists and astronomers, it has been determined that the diameter of the orbit of this binary system is 10 to 100 times smaller than the orbit of the only other known supermassive binary system. This indicates that the pair will merge approximately once every 10,000 years. Although a merger once every 10,000 years may seem like a long time frame, it typically takes approximately 100 million years for black holes of this magnitude to start orbiting each other before ultimately colliding and merging. Given the positioning of the two black holes, it appears that they are currently over 99% of the way towards a collision. At NASA's Jet Propulsion Laboratory in Southern California, researchers Joseph Lassio and Michelle Vallis-Neri provided insight into how the binary system between the duo of black holes work, and how one can interpret the radio data that is generated by their collision. The observation that the supermassive black hole had a binary companion was made through a radio telescope from Earth. As we mentioned earlier, black holes do not emit light. However, their gravity can generate disks of hot gas around them. They could also eject material into space while doing so. Jets are generated, and they can stretch for millions of light years. If a jet is pointed toward the Earth, it will appear far brighter than a jet that is pointed away from the Earth. Astronomers have noted that supermassive black holes with the jet orientation can give rise to blazars directed towards Earth. The blazar being studied in relation to the collision of the two black holes is currently PKS 2131021. PKS 2131021, one of 1,800 blazars being monitored, by a group of Caltech researchers located approximately 9 billion light-years from Earth. For the past 13 years, these researchers have been using the Owens Valley Radio Observatory in Northern California to study blazar behaviour. However, while monitoring PKS 2131.021, the researchers noticed irregular behaviour in the brightness and flares of the blazar, which exhibit periodic fluctuations. This has sparked numerous questions and theories surrounding its behaviour. After extensive contemplation and research, the researchers have arrived at the conclusion that the regular variations observed in PKS 2131.021 are likely caused by the second black hole exerting a gravitational pull on the first black hole as they orbit around each other every 2 years. Recent observations suggest that the two black holes in PKS 2131.021 are estimated to be several hundred million times the mass of the Sun. To validate these findings, scientists are examining data on gravitational waves, or ripples in space, emitted by the black hole duo. The gravitational waves from this system were first detected in 2016. To confirm that these oscillations were not random or a result of some other phenomenon, the research team examined data beyond the decade of observations from the Owens Valley Observatory. Specifically, they analysed data from 2008 to 2019. Upon further investigation, it was discovered that 2 other radio telescopes had also studied PKS 2131.021. The University of Michigan Radio Observatory had monitored the system from 1980 to 2012, while the Haystack Observatory had observed it from 1975 to 1983. These additional datasets aligned with the predictions for how the blazar's brightness should change over time. Researcher Joseph Lazio stated, "This work is a testament to the importance of perseverance. It took 45 years of radio observations to produce this result. Small teams at different observatories across the country took data week in and week out, month in and month out to make this possible. There is plenty more to learn about this duo, including the characteristics of such a merger as well as the effects that it has on its neighbouring interstellar bodies. Only time will reveal what its true significance is and if it is lethal or not to us humans." What are your thoughts on PKS 2131.021? Do you think the collision of black holes will affect the people of Earth in any way? Please share your opinions and ideas about the collision of black holes in space in the comments section below. We would love to hear from you and engage in a conversation about this fascinating interstellar phenomenon.